Here's part 2 of the snack in the middle task. Now, Clyde and Maddie are working at trees located at 6, 2 and 11, -4. Where should they set up the table? That should be exactly in the middle between them. Prove your choices equidistant from 6, 2 and 11, 4. I've already drawn the grid here. 6, 2 is right here. There's one person. 11, 4. Darn it. The 11, -4. I messed up the x and y axes again. Okay, so -1, -2, -3, -4, x, 7, 8, 9, 10, 11. Here's the other person. 11, 4. Let's label this 6, 2, and down here 11 for the x, -4 for the y. I'll use two colors once again to label the change in x, and here is the change in y. Here's orange. Here's the change in y. I'm going to use a straight edge, unlike what I did before, to draw in the line between that diagonal over here. A little bit harder to tell this time. 1, 1, 2, 2. I think the middle is about here. Alright, so this one, that looks visually like the middle, but it's harder to tell where the middle will be, so we have to come up with something clever. If I notice 2 to -4 for the y, so I'm looking up and down, that's a total distance of 6, so it should definitely be here. Okay, that's middle for the y coordinate, so I'm splitting it this way. And then we notice 6 to 11, that's 5. Middle looks like it's over here, 2.5. Okay. And now our goal is to figure out where that is. We notice that if this distance in pink, right, is 1, 2, 3, 4, 5 total from here to here, and then in orange, it's right along the grid line, so this distance is 6 in total. The 2 halves then has to be 3 and 3. Likewise, up here, half of 5 is 2.5 and 2.5. So we can generalize this and show that the midpoint here is 2.5 from 6. So the x-coordinate is 2.5 from 6. And the y-coordinate, let's think about this, -4 and 3 up. So it should be 8.5 and -1. Let's confirm. So in gray, we notice we have a right triangle over here. 2.5 is the distance on this square, and going this way we have a square that is 3 big, like that. Which means that this thing is the sum of those big squares. So we know that this thing is 2.5 squared plus 3 squared. We see that 2.5 times 2.5 is 601. Doesn't look like I did that right. 5 times 625. 6.25. That seems about right. 625. So 6.25 plus 9, which gives us 15.25. The distance is therefore the square root of 15.25. So we need to get that again down here in brown with those similar measurements, and I hope you're noticing a pattern at this point. This square is 2.5. This square is 3. So this square is 2.5 squared plus 3 squared. That's again 6.5 and 9, which gives us 15.25. Square root of 15.25 again. Okay, we've proven that this distance right here is the same as this distance over here. And it looks like we can save some time now. Strategically, we notice that these halves have relationship with these coordinates. So here, this distance and change, these half distances and these coordinates over here have a relationship. Just like from before, we're messing around with those change in x's, and now we're having them. And then over here, we have 6.5 plus 2. This main idea in blue that I'm going over, okay, 6 plus half of 5, negative 4 plus half of 6 gets us to our midpoint. Okay, that idea was present in our previous one, whether we noticed that or I'll highlight that now. So in red, this thing was our midpoint, 1, 8. 1 should have been this distance, right, 4. So if we add negative 3 plus 4, going for the x direction, negative 3 plus 4, right, here's negative 3, then we go this way, plus 4, we get the x coordinate of the midpoint, that's 1. And then for the y, we start with negative 4, and then positive 4, and then we go up 4. 4 plus 4, oh look at that, it's 8. We'll confirm with number 1 up here. This distance was 4. This distance was 3. So 24 plus 3, because that's the change in x, that was 27. Oops. Right, this is the graph where my numbers are a little bit weird. 27. That's the x coordinate. And then for the y coordinate, 6 plus 4 gets us to 10. Oh, look at that. That's the same as our midpoint. Looks like that's always going to work, and we can generalize that even more. The main takeaway is this midpoint formula. Say we have a point here, x1, y1, and then down here we have a point. I'll make it really big. Oops. Oops. Go away. Over here we have some point way over here, x2, y2. We can draw a right triangle that connects them. Use a straight edge again. Here to here. About halfway in between. Things seem to have frozen. Give me a second. Okay, things are back. So let me draw again. This thing is our, this thing is our line. About here is the midpoint. And right now we're trying to find a shortcut to get us there. So in orange, we'll label one slope triangle. Here's the change in x. And then maybe in blue, here will be the change in y. Half that distance, right, is, because the whole thing right? Going up and down, that's change in y, which we know as y2 minus y1. So half of this distance, like here, just that, is change in y over 2, which is equal to y2 minus y1 over 2. Okay, so we went down, not the entire ways, but halfways. We're only looking for half the distance now. And then in purple, or pink, notice this whole distance from here to here is the change in x, which we know is x2 minus x1 from our work with the distance formula. Halfway is about here. Half that distance is the change in x over 2. x2 minus x1 over 2. So it doesn't matter where we label it, these are its two halves. So over here, it's change in x over 2 also, x2 minus x1 over 2. And in blue, just to be complete, this distance going down is again that change in y over 2, which is y2 minus y1 over 2. Okay, it goes like that, and like that. So if we consider the start, okay, to be maybe right here, I start there. If I go down this distance, and then I go over this distance, I'm going to end at my midpoint. So in other words, if I start at x1, and then y1, I can add on this change, which we know what it is. It's right there. For the y coordinate, plus y2 minus y1 over 2. And then for the x's, we can do the same. This distance we know, so we can add on x2 minus x1 over 2. And that's how we get our midpoint. Start there, figure out the change, go there, start, and that could have worked this way too. You could have started or x2 comma y2, go this way, add on x2 minus x1 over 2, and for the y, adding on y2 minus y1 over 2. I'll pause the video.